Okay, so let's see for this one. Oops, let me get that scooted over a little bit. We're looking at this equation and we're asked to find all kinds of stuff. So first off, for standard form, let me just point right down here to the answer. This is all that is looking for, is for you to write that 4 is a 2 squared and for that 25 is a 5 squared. If you look up in the intro to the homework, you'll see there's some directions saying which problems want that silly notation. But that should solve that piece of it. So, okay, once we got that out of the way, let's figure out what this graph looks like. And I mean, you can do this with algebra or just even arithmetic. But for me, unless I draw some kind of little sketch, I get all mixed up as to what went where. So I'll show you how I would do it. I would start with my center. So it looks like we have minus 2, so that would be at 2, 2, because remember it's backwards what's showing. So there's my center. And then the big numbers under y, which means this is going to be a tall, skinny ellipse. So 25 is a squared, so a would be 5. So we'll go ahead and count up 1, 2, 3, 4, 5 from there. And then same thing, we'll count down 5, 1, 2, 3, 4, 5. And what that should give us is the endpoints of the major axis because a is 5. So right here we ended up with 2, 7 and 2, negative 3. And that's exactly what this key is showing right there. So next we know the smaller of the two numbers for an ellipse, that one's going to be b. So b squared is 4, and so b would be 2. So for the endpoints of our minor axis, from the center we would count right 2 and left 2. And so there's the 0, 2 and the 4, 2. So again, you could do this by adding and subtracting from the center, but I get my up, down, left, and right all mixed up. So for me, if I just do that quick little sketch, that's a whole bunch easier. The foci, now these are a little bit harder. Let me show you how to do that. So I'm going to scoot this over here, bring that in. So what we need is c to figure out where the foci are going to be. So for an ellipse, this is a squared minus b squared equals c squared. And we know that a is 5. Whoops, come back here. A is 5, and we know that b is 2. I could also just write 25 and 4 in there, but here it is as a squared minus b squared equals c squared. So that's 25 minus 4, so that is 21 equals c squared. And so then rooting both sides, we get c equals plus or minus square root of 21. So square root of 21 is going to be like, let's see, square root of 21 is about 4.6. So in terms of, this is our exact answer. This is what we want to look at as we're going to write this part here. But let me point out that what this is saying is this is going to be plus or minus approximately 4.6. So when I go over and show it on the graph, that will make more sense and why we're going to get this weird answer right here. So let me get the graph back now. The foci are going to be located above and below the center because this is a transverse a parallel to y ellipse. And they're going to be about 4.6 units above the center because that's the positive one. So it'd be, like there basically, and 4.6 units below the center. So about there. So then it comes to how do we write this? So what we do is for all of these, notice the x-coordinate is 2. So if we're trying to write the foci, the x-coordinate is going to be 2 because everything's happening along the line x equals 2. And then we started from the center, which was also happened to be 2, but this is because of the y. And then we either went up root 21, or we started at the center at 2 and we went down root 21. And that's where this distance is coming in. We're starting at 2 and going up that many boxes or down that many boxes. And so that's what you're seeing here for the foci. Hopefully that helps clear that one up.